The future is coming. Sit back and enjoy the show.
Good afternoon. Welcome to ET Talks Special Edition. ET Talks are a series of events, interviews, publications driven by Danfoss. And we began this a little over a year ago in Warsaw with a gathering much like this. Utility professionals, public administration people, engineers. We followed this with another gathering in Kiev a few months later, and then towards the end of last year, we took interesting people out of COP24, put them into an electric vehicle and took them for drives around the city and asked them questions about sustainability and engineering and finance and policy and all those sorts of things. And today we are at Nantes. Since the beginning, we have really concentrated on two trains of thought, if you will. One is the fact that the engineering solutions required to build a future that doesn't look like a disaster movie are already here. And the second train of thought, that the responsibility on us to speed up the process, to move faster, to reach with greater ambition towards that net zero future also is a driving principle. My name is Ralph Talmont, and it's been my pleasure and privilege to be the host and consultant on this project since the beginning. And today we are trying a new format, this special conference edition, and we're very thankful to Euroheat Power for this invitation to be here. We're going to be talking about how district energy has the potential and really the responsibility also to be a key part of the energy puzzle going forward. We're going to hear from our three speakers, then at the end we'll have time for a little bit of a conversation. And I would love you guys to take part in this conversation. There is an app which resides over there. If you head for that address and key in that code, let's leave that on for a second. You'll be able to participate in the conversation, and that also goes for all the people watching on live stream, and a especially warm welcome from sunny Nantes to you. And with that, it's time to introduce our first speaker, who, as the CEO of Lean Heat, really has a deep understanding of the vast potential that is held within the existing building stock, the potential to save our climate just as we are saving money. Please welcome Jukka Aho. I'll get the
Good afternoon. Have you ever played a game called Alias? For those of you who are not linguistically minded as kids, Alias is a board game where the objective is to explain a word to each other without actually using the word to be explained. So it's a bit like catchphrases. So you can talk, you can use expressions, you can even sing, but you just can't use the word. In Finland, where I'm from, Alias is a very popular game, and it's highly competitive too. Back in the day, when I was in elementary school, there was one day we played Alias in the classroom, and I got the word jet plane to explain to my classmates. And I started dissecting the word and dividing it to its pieces, jet and plane. And in Finnish language, jet is a synonym for shower, and plane is a synonym for machine. So this was my strategy to explain the word. So, you can only imagine how long time it took for me. First I played that I was under the shower. Then I pointed out a computer in the corner of the room. And finally, my classmates were able to crack the code. And I felt that, yes, I nailed this. This was the best way to explain the word. But after the class, my classmates came to me and said to me that, why did I choose such a complex way to explain the word? Couldn't I have just shown an airplane in the air and said that it's a transport vehicle of sorts in the air? It didn't come to mind, but that seemed like an obvious answer to the question. And this was the first day I realized that I am an engineer. As engineers, we sometimes see the world in such a black and white manner that we actually fail to see what's right in front of us. As engineers, we like to solve the complex problems instead of the right problems. And today, climate change is one of the biggest problems we engineers face. And the answer seems quite simple. We only need to have a world where all production of energy is 100% sustainable, 100% green. We need a world where all transport is electric, cars and ships. We need a world where all buildings are carbon neutral and energy neutral. We need a world where we only use energy when it's available from renewable sources, so that we wouldn't have to use fossil fuels. It sounds very simple, but for us to do this, we would need to replace all the infrastructure we have in the world today. And what would be the cost of that? The unfortunate truth about climate change is that the longer we wait, the higher the cost. And the cost of inaction is even higher. So we need to look at climate change from a different angle. The key issue is not technology. The key issue is how can we tackle climate change by using the infrastructure we have today. So back in the day in that classroom when I was playing Alias and explaining jet planes as shower machines, I learned that sometimes we need to tackle problems in a new way, even if it doesn't seem obvious. And today I ask you that let's look at climate change from a different direction. Let's reimagine our problems so that we could first grab the low-hanging fruit and do what we can do already today. Buildings, they consume 40% of all energy globally, 36% of all carbon emissions. They are the biggest consumer of energy. And of course, a lot has been done about these buildings, but that technology has been especially about new construction and deep renovations. The problem with this is that it only renews the building stock by about 2% each year. So it would take us 50 years to fix that 40% efficiency problem. And that's time we don't have. So what can we do to attack this 40% of energy consumption? Well, we can do something not about that 2% of the buildings, but that 98% of the buildings that are already there. So you as building owners, as district heating utilities, you can start doing something small. Together, we can use existing buildings to make tomorrow's energy systems. It's actually quite simple. First, we need to make our existing buildings digital and efficient. Second, we need to make these buildings active part of the energy system. We call them virtual heat plants so that they can increase or decrease consumption as fit for the energy system. And finally, we need to optimize the whole energy system so that it can take use of these virtual heat plants. If we would do this, we would have an energy system that's climate friendly, efficient, and flexible. Who in here is a building owner? Any building owners? No building owners today. Okay. Oh, there's one. Okay, great. So, as a building owner, you have a lot of buildings. You know that some of your buildings are overheated. You know in some of the apartments you have inhabitants who have hot temperatures, some have cold, and not all are happy with the comfort levels they have inside. By making your buildings digital, you can reduce consumption by up to 20%. You can reduce the peak load of the building, but also you can improve the comfort of the inhabitants in those buildings. Who in here is a district heating utility? Hopefully more hands. This is a utility conference, is it? Oh, at least one, two. Yeah, good. There's many of you. Okay, for you, I see a future that, buildings, as they get better and better in future, they are consuming less energy. But still, during the coldest months of the year, you need almost the same amount of peak load, peak capacity to meet that demand. And this is a problem because at the same time you are supposed to be more green, you need to compete with alternative energy sources, heat sources. So it's a complex equation. By making your buildings digital, you can cut peak load requirements by 20%. And instead of using those oil or gas-based boilers, you can produce energy, even in the cold months, more in your most economical and efficient facilities. This way you improve your margins. It's basically that we are deciding that should we burn more or should we cut demand? And cutting demand is cheaper than burning more. These investments today have about 2 to 4 year payback times. At the same time, we improve your customer relationships, and also we can cut CO2 emissions by up to 10 tons per block of flats per year. So this truly is a model that benefits all of us. Let me explain how this is done. So let's start. So when we are starting to build that building of that really efficient energy system, the first step is to make our buildings digital and efficient. They consume 40% of all energy, and they affect the way we live our lives. Simple things can make a big difference in these buildings, to energy waste, to cost of energy, to the healthiness of the building, to the comfort in the building. If we would use digital technology to control the central heating systems, there would be huge potential for efficiency. Imagine that you're living in a sensing apartment. Wherever you go in the apartment, from bedroom to kitchen, the heating is always following your needs automatically. Imagine you're living in a building where the whole central heating system is optimized, adjusted to charge and discharge heat based on the tenant's natural rhythm of life. Life is unpredictable, so is weather too. So what if during those sudden cold April days, instead of you having to turn up the heating, the system would do that automatically, and more efficiently than you ever could. We can do all this today. It's actually quite simple. We put sensors inside the rooms to monitor indoor climate. We connect to the building heating controllers, and we use artificial intelligence to process this data. And with this process, we create a digital building that is optimized to your life, that is optimized to consume less energy, to consume less peak loads. Do you know how buildings used to be heated, or are heated today, but used to be also heated back in the day? Let me tell you a story of a janitor. Let's go back a little bit. Let me tell you a story of a janitor called Ted. You should see the picture of janitor Ted. Okay, you are not seeing that, but you can imagine now Ted putting some coal into a boiler. So back in the day, Ted would live at the building, would be living there close to the heating room, and every morning Ted would go outside, feel the air, look at the clouds, and then go to the heating room to put coal to the boiler. And if he did his job right, everybody in the building would be super happy. If not, maybe somebody from the cold apartments would yell, "Ted, more heat!" Something like this. And over time, Ted would become, an expert of how to heat that building. The intelligence of heating would be in his brain, it would be janitor intelligence. And even today, most of our buildings are being heated with janitor intelligence. You know, we have things called heating curves and a lot of technology, but in essence, it's based on janitor intelligence. And now when we do digital buildings, we are actually replacing this human intelligence with computer intelligence. And computers, they actually do this better than humans, cheaper than humans. We can get better comfort and better efficiency. Okay, so now we have made our buildings digital and efficient. The next step is to look at the neighboring buildings. You know, what if we could connect all of the buildings together to make them, instead of just consuming energy, also to store energy? What if the biggest consumers of energy could be storages of energy? You know, this is what we call virtual heat plants. So basically the idea is that we can increase the indoor climate a little bit and store energy into the building. Imagine during the night when you're sleeping, there's no demand for energy. At that moment, we can charge energy into the building. And now imagine you're waking up, you know, you're taking a cup of coffee, going into the shower, and everybody else in the building is doing the same thing. It's basically like a rush hour of the heating system. At that moment, we can locally respond to that risen energy consumption from the storage we use, the virtual heat plant. So, and if you think about utility, this is a way to match supply and demand. You know, during those peak hours, the utility can use their most economical facilities to produce that energy. And that way they improve their margins. Flexibility has been, you know, we've been looking for flexibility from many places. In Finland, we love saunas. You know, almost every home in Finland has a sauna. We have more saunas than cars, and we do have a lot of cars as well. And of course, back in the day when we talked about flexibility, somebody said that could we find flexibility from saunas? But actually, it's not such a great idea, because often when, at least Finns, when we get out of sauna, sometimes we leave some towels or textiles to dry next to the stuff. And if you would remotely activate the stuff, it could light a fire on the towels. So that's not too safe. So actually, using buildings for getting flexibility is much, much, much safer. It actually, we can do shifts of energy that are significant without affecting indoor climate. And it's also good business. For example, in the city of Kankaanpää, they were able to get almost 50% of suitable buildings connected to the virtual heat plant in a matter of 3 months. And at the same time, improve customer relationships and margins, etc. In China, there's a lot of utilities that are looking for ways to get rid of their coal-based baseload to shift to gas-based baseload. But the problem with gas is that it's hard to match the peak capacity of coal. And then looking at buildings as a virtual heat plants is one way to tackle this problem. Okay, so now we have made our buildings efficient, digital. We have connected them together to make a virtual heat plant. Now it's the final step. We need to optimize the energy system to be able to use more renewable sources. You know, the amount of renewable sources is increasing all the time. Imagine during the night when you're sleeping, the wind is blowing, the waves are splashing. Now we get a lot of renewable energy, but that's not used. And then imagine in the morning when we have that rush hour of the system, what if wind is not blowing anymore? We need to use fossil energy. So in future, it will be more and more important for the utilities to be able to match these renewable supplies that are not always available. We can have solar thermal energy. We can have industrial excess heat. There could be energy from supermarkets, from data centers, even large-scale heat pumps. And when we connect these to the district heating utility, the challenge is that we need flexibility. We need to be able to decouple the supply and demand. And this is where having these digital buildings is really handy. Also, we will see a future where there's more players entering into the utility. Maybe a data centers person comes to you and says that, what if we had this much heat? How much would you pay for that? Even local buildings could have local heating and storage that they could sell to you when they don't need it themselves. So the future of utilities is not about using a few points of production to meet a known demand. Instead, it's a complex equation of matching complex supply to a complex demand. And who will win this game is the one who can match these two at the best price point, you know. Because that's in the end, you want to pay the best price for the suppliers of energy, but at the same time give the best price for your consumers. So you need to decide which production to use when and where. You need to decide which storage to use when and where, and it's a complex equation. Luckily, there's a lot of digital solutions that are coming up to solve this problem. So, now you know how we can attack this 40% of energy consumption. We can make our buildings smart, we can make them digital, and build an energy system that is efficient, climate-friendly, and flexible. And you, as district heating companies, as building owners, you only need to start somewhere small. Together, we can build this energy system. If we want to do this, we need to do 3 simple steps. We need to make buildings digital, efficient. We need to make them active part of the energy system so that they are virtual heat plants. Then we need to optimize the whole network, or the whole energy system. And if we do this, we will get loads of benefits. You know, we will have that tomorrow's energy system. For building owners, we will have more comfortable indoor climate, lower bills, less energy use. For utilities, we will have 2 to 4 year payback time. We will save more than 10 CO2 tons per building per year. We can improve the customer relationships. This is a model that benefits all of us. You know, back in the day when I was there in the school, elementary school, thinking about jet planes and shower machines, you know, I've gone and thought way past shower machines by now. You know, I'm ready to, I've been, facing challenges and done approaches that are unfamiliar and not always comfortable. The key challenge of climate change is not technology. The key challenge is, are we ready to take the leap to unfamiliar areas? I ask you to take that leap, not only for the climate, but for your business. And what I can guarantee is that we will jump with you. So together we can build the energy system of tomorrow. Let's do it. Thank you.
I need the clicker. I'll have that back. This is the most crucial piece of equipment in the room. Without this, we die. I love engineers, and I particularly love engineers who can so simply explain why what they do is so important. If you have questions, magic, I didn't even touch it. If you have questions, please just head to that address and we will address them at the end of the session. We talk a lot about putting together pieces of the puzzle, and most of the time it's virtual. It's about the conceptual puzzle, but sometimes it's actually about real physical puzzles. And somehow district energy, to me, seems like a really elegant way to demonstrate how putting together physical pieces can really transform the whole into something greater than the sum of its parts. And there are few people better qualified to talk about the mechanics of this than an engineer who has spent his career creating such systems. Please welcome Benjamin Brulon. Oh, you're clicking. Okay.
Oh, yes, it works. Okay.
It's one small step for man, one giant leap for mankind.
In 1961, John Fitzgerald Kennedy, the president of the USA at this time, gave a speech at the Congress. He proposed something. He proposed that the US should commit to achieving itself the goal of landing a man before the end of the decade on the moon. and of course, go back safely to the Earth. Why moon landing is so fascinating until today? Because it is a story of someone that fixed a clear goal and achieving it. He said, let's send a man on the moon and go back, and that's what happened. Do we have this vision today for our sector, district energy, district heating and cooling? A kind of. We can agree on some things. District energy in 2050 will be greener, smart, connected. Okay. District energy will have a key role in the energy transition. Do you know this number just behind me? 50% energy, district energy in Europe by 2050. This is a clear goal, an exciting goal. This is our moonshot. It is a figure of its roadmap Europe. But are we acting today? Are we acting today like we wanted to reach that goal? Really? I ask you. No, not really. Not really. We're still implementing district heating slowly, not at the big scale we need. If we take it seriously, we should do it much faster. We have to implement district heating, district energy in general, in a new way. In 1961, after the speech of Kennedy, the second question after the what the clear goal, going to the moon, was the how to achieve it. The how is what I want to talk about in the next 10 minutes. How to industrialize the whole process of implementing the district heating system, from the feasibility studies to the operation. Industrializing district heating is shown best by Lego. You like Lego? No, you don't like it. I like Lego. I played Lego when I was a kid and still play Lego with my kids. Legos are fantastic because they are simple, modular, easy to produce, reliable. With blocks of Legos, simple blocks, we can easily and quickly create complex things. So now let's go into details of the new approach, the industrializing approach. It is a three-part approach. First, we have to industrialize the studies, the feasibility studies, to have a plan, a clear plan. The second part is how to make the commercial approach more efficient, to create new networks, especially for small cities. The third part is that we need technical standards. So, first, the clear plan. When we have a clear goal, we need a clear plan. In my experience as a consultant, when I work for French cities, is that the best plans are the ones you study the networks from the future, from the objectives, back to the present. We don't do that today that much. We always start from the present, look at the existing networks, and we try to develop them, to improve them, to make them greener, which is good. But it's not enough, because when you do that, you miss project. You restrict yourself. So instead, we must to start from the future, from our objectives, and study all the networks we need until we reach our objectives. But let me give you an example. A first example, the moon. When they decided to go to the moon, they did not ask, how far can we go to the moon? They went to the moon, not halfway to the moon. So let's take the example of the city of Bordeaux. The city of Bordeaux took this approach. they define an objective, a long-term objective, according to the objectives of the energy transition French law, and also according to their climate plan. For them, it means that they need to double the district energy from 400 gigawatt hours up to 800 gigawatt hours. They define it, and after that, they study district by district, systematically, where to implement pipes, new networks, until they reach the objectives. We can do it at a large scale, at the scale of a region, of a country, maybe also at the scale of the entire Europe. Let's look at the French case. In my engineering company, we started to study how to reach the objectives of the energy transition. 40 terawatt hours of green energy delivered by district heating. It's quite easy to start. It's quite easy to know how many kilometers of pipe we need, how many substations we need, how many megawatt of green energy plant we can install to reach the objective. The next step is to find and to decide where to implement all these pipes. It is about 9,000 kilometers of networks, double if you want the kilometers of pipe. And that's not that difficult. We also estimate the investment of all that. It is about 15 billion euro. Don't be afraid by this figure. It's just quite a bit more than a nuclear power plant, the one we try to build, which is 11 billion euro. In terms of planning, our objective of the French energy transition law is an objective in 2030, 10 years. It is a time to build such a plan. But just stop here the comparison, it's not our subject today. Let's go back to our approach. By conducting studies in a strategic way like that, we create a big master plan, a national master plan. Imagine what can we do, what can we do with it? It is also a huge market study for our sector. This is the point number 2. The point number 2 is the necessity of creating standard commercial approach, standard offers for small networks. It is a suggestion for the private sector, for private operators here. With a good market study, you have a very accurate idea of what all the small cities need in terms of networks, depending on the density of the volume of them. Big cities can reach their objectives by themselves. They are big enough, like Bordeaux. But small cities need help. Consulting company like mine can help these small cities, but there are thousands of networks to create. We have no time to do thousands of procedures that takes years and years all around the country. We have only 10 years. So what I suggested that operators could propose turnkey solutions, standard commercial offers with standard prices based on standard parameters like density, volume, the energy you choose, mostly biomass, of course, for small cities. Instead of reacting to tenders of big cities, just reacting to tenders of big cities, you should take more initiative to propose private solutions to these small cities, the cities of the master plan. Of course, this offer should be packaged with no risk of trap for these small cities. We can help in that way. Okay, so once we have commercial offers to implement all the network we need in a country, we also need technical standards to define these commercial offers and to be efficient. This is the point number 3. Every day in my job and with my colleagues, we are often angry with one thing, that is, for each project, everyone, even us, try to reinvent district energy, try to reinvent standards of the substation, how to design it, how to buy it, even for selecting the pipes. It is a huge waste of time. We don't have time. It is a huge waste of human resources. We are not enough. So don't get me wrong. It's no question here to kill innovation and so on, but most of the times, systems can be more simple. On top of that, we don't have technical staff to manage and operate all these complex small networks. We need something simple. So maybe we should think about more plug-and-play systems for our district energy equipments, modules. It's not possible for the entire networks, but you can take the example of substation. We can fix, for all of us, pressure parameters. Pinched is the difference between the inlet temperature, outlet temperature. To make them more pluggable, the communication rules also. We can also agree together to define the rules of selecting a pipe. We can also define rules for parts, standard parts of heat plants. The benefits of such an approach should be that we will save time. It's going to be more cheaper to study and to implement a network. Networks will be pluggable, one with the others also. Technical standards for our sector is an urgent need. They did it in the electricity sector in the middle of the last century. All is interconnected today, and nobody intends to question the standard voltages, standard frequencies. So our networks, our heat and cooling networks, can be smart and simple. I would add that if they are not simple, they are not smart. So, as conclusions, let's be smart, stop waste time. We have to create this big master plan. And thanks to this, we could implement district heating much faster from the feasibility studies, by industrializing feasibility studies, commercial approach, technical standards. We can reach our goal. We can reach our big common goal. At the scale of Europe, 50% district energy in 2050. This is our moonshot. And I have a good news. Implementing district energy we need is much cheaper than landing someone on the moon. So thank you, and let's go to the moon.
Thank you, Benjamin.
Thank you.
Thank you for these ideas around engineering tomorrow. Now, some of our speakers, or all of our speakers, if you're lucky, are actually going to hang around the Danfoss stand, and they will be available to buttonhole and ask questions. Now, I'm a communications guy. So really, every problem to me looks like it's rooted in communications, and improving communications improves the likelihood of finding a solution. I think our next speaker is probably going to agree with me on that. She has taken a long, hard look at what it might take to improve the public image, say, of district energy, and she's going to present that with a sprinkling of humor. Please welcome one of Europe's finest communicators around the issues of policy and European affairs, Florence Russell.
Good afternoon, and I must apologize for my voice. At least I have a voice. Tomorrow, maybe not. I'm going to talk about rebranding the district energy sector and what if it were a person. Rebranding is a little bit like a makeover or a diet. You know, it's the sort of thing that you would like to do. You know it would be nice if you did it, but most of the time you think, yeah, tomorrow, in a month, you have all sorts of good excuses not to. And when you decide to do it, or if you decide to do it, you know you need to make the decision at the right time. Because if you don't make it at the right time, in the right circumstances, you're not going to stick to that decision. And I'm sure we've all been there at some point. So I will introduce you to somebody, and when I talk about that person, I would like you to think of this guy as district energy. Hi, I'm Peter. Peter. No matter how you say it, no matter where you're from. Pretty universal name. I'm Mr. Nice Guy. I'm ordinary. I have a few good traits about me. I'm generally considered as very reliable. I'm taken for granted by my friends, by my family, by my colleagues. I'm pleasant company. I may not necessarily be top of the guest list if they want to have a wild party. I'm just, you know, nice to be with, reasonable fun, around. People see me in the street, but they don't look at me. I'm seen by some people as pretty trendy. Others see me as old-fashioned. And when they see me as old-fashioned, sometimes it's because I remind them of things they've known in the past, and they don't want to come near me. So with all that in mind, I started thinking that maybe I should reflect upon what they think of me. I mean, after all, I have been around for a while. I'm, I guess, middle-aged, although I read recently that middle age is 35, and I thought, maybe not, you know, that may have been true 60 years ago, but probably not anymore. But with middle age comes midlife crisis. The point where you question everything and you think, you know, where do I come from, where am I going, and what's good for me? And that's what led me to decide that maybe if I took a good look at myself, it would help me change things and improve the situation. I have assessed, we've just been through it, what others think about me. I have assessed what I think about myself or how I see myself. And that led me to realize that, in fact, it's not that people know me. They don't know me for who I am. They perceive me a certain way. It's all about their perception of me. That was my starting point for my trip. I had decided I was going to make that decision. I'd taken the first step. And when I started doing that, I started thinking, okay, what do I do now? You know, where do I go? How do I reach that goal that I have set myself? My goal is to be a reference in my own league as of now. We'll skip this one because it wasn't a very interesting point, and I think it's better that we save some time to go back through the process at the end. I decided to put myself in the spotlight. It's all going to be about me from now on. And by putting myself in the spotlight, I decide that I am reliable. I know that. I'm taken for granted. I know that. Good. Then, if I'm in that spotlight, I need to move ahead. And I need to reflect upon how people will definitely see me in a different light. To do that, I need to bring out things in me that they don't expect about me. So if I start thinking of a little trait of my personality that they will not have thought about, something that they won't take for granted. For instance, if somebody at a party says to someone, "Oh, you know what? I was at this party last week and I saw Peter. He was mixing cocktails. He's a great cocktail mixer. I would never have thought so. He did not seem the type to me." Then they are spreading the word about me. That is so much more efficient than if I do it myself. So I have given them a new trait of me, and I have helped them reach out to other people to promote that trait about me. How am I going to succeed in this new approach? I have a few talents. I'm a great bridge builder. I have a pretty good network of people. And I decided that, in fact, if I want others to talk about me, I need to bring them together. I can be a catalyst. I can be a federator. I can bring all these energies, all those ideas around me, bring them together. By doing that, I can help them think of possible alliances, possible projects. I can lead on things rather than being one in the crowd and being one of the people who follow ideas or team up with others. I can be the person who brings these guys together and help them go ahead with new ideas. I can broaden their horizons. I can even reach out to other people whom they may not have thought about. Because as I'm an external person, as I said in the beginning, because I'm so reliable and I'm sort of Mr. Easy Guy, I'm not considered as one of the in kids. But I know the in kids. And what I can do is introduce one of the cool kids to another one of the cool kids. And being the catalyst, being the intermediary, is what's going to help me build on my own traits to deliver to other people. I must be, when I do that, my aim is to show that in a quiet, authoritative manner, I'm actually a reference. And remember my goal from the beginning? I want to be a reference in my own league. That's what's going to help me become one, by being that catalyst and by being that helper. And I must be careful, because if I sound desperate, if I portray myself as too good to be true, I'm going to be just like on one of those dating apps. You know the way. People who sound all good, all fantastic, all, the person, the best candidate. First of all, you start thinking when you read their profile, well, why are they there if they're that good? And it's a deterrent. It means that nobody's going to click on your profile because they're all going to think, too good to be true, I'm not buying it. So what I must do when I portray myself, what I must do when I make myself available to be the intermediary, is I must also acknowledge my weaknesses. By acknowledging my weaknesses, I can anticipate criticism, and I can actually block possible attacks on me, because I say, look, this is what I truly am. This is good about me, this is not so good about me, but I know it, which means I'm working on it. That's a great step forward. So, to recap these various stages, I have acknowledged the good things about me. And I know that I am reliable and I deliver. I know that there is more to me than meets the eye, and I should show that. And I also know that I have a great network, and I can use that network and build on it. Now that I know these 3 traits about me that others don't necessarily know, I can use them in everything I do. I can make sure that whether it is in my daily work, in my contacts with potential clients, in my contacts, in my social contacts, in my life with my friends, these traits become my brand. That's what I want to be associated with. That's what I want to be recognized for. And once I have established that, then I can move ahead and start on my plan and develop these various traits and these various approaches that I have already highlighted. And if you think about what I said in the very beginning, think about Peter as district energy. District energy is a sector that has all the tools. I mean, we have just heard it. We have heard that you should have the goals, you should have the ambitions, you have everything it takes to have these ambitions and to reach those goals. But maybe there's a bit of taking yourself for granted. Maybe a first thing to do would be to better assess what others see in you, how others perceive you, and what you know you have as your best qualities. Also know what your more difficult traits are, so that you anticipate criticism. Once you have assessed that, you embark on your journey. You make your decision. Now, making the decision is something different because, as I said, it has to be done in the right circumstances. It has to be done with the right people. And maybe you are not the person who can make that decision for your organization, but you know the people who can. Go to them, talk to them, empower them, help them, support them. Show them that making the decision may be a bit costly, may be a bit difficult, but it will make a difference. And that's what teamwork is all about in the end. And once you have done that, you need to make sure that you have established in advance the list of one of the favorite words in the European jargon, stakeholders. So your list of stakeholders, your list of target group is well established so that you know where you're going to go, who you're going to reach out to, so that these people in return can come back and help you and tell you, yes, we'll team up with you, and we'll team up with you because we like your qualities. We knew about you, but we did not know this or that about you. And once they know, the word will spread. So get the ball rolling, and it all starts with a simple decision. Thank you.
Thank you, Florence. Please don't go away. Now, if I might ask our other 2 speakers back up on the stage. Yes, well done. Are they beautiful? Look at them. Very, very brave. And thank you for sharing all these engineering words into action ideas. We've got, how much time do we have? Well, about 10, 12 minutes, plenty. We're going to have a conversation around what you guys have been talking about, and also around the questions that have come from here and from the live stream. So I'll get rid of this magic number. Retrieve a vital piece of technology so I can actually see what these people have been saying. The questions really that have been coming in are naturally engineering questions. You might think that there might be one or two engineers in the room. I don't know. Are there? Yeah, waving.
It's hard to see from here.
Yeah. But let's wait with the engineering questions for just a moment, because we kind of, well, it's my job, so I'll start with what I'm interested in, the big picture. And the big picture really is that we have a context, a global context, where there are tons of skilled people, there are tons of solutions, there are any number of engineering tools available. Of course, people are talking to each other. There is consolidation, there is communication, but not enough. What can we do, Florence, to you as a communicator and as someone who's just been tickling the bones of public perception? What can we do in this room right now, today, to begin the process of helping others out there who haven't been listening to this to
actually
work together better?
As a newcomer to this sector, I had to look up some information before I came to talk to you, because I must admit I did not know much, if anything at all, about district energy. And I thought that, I read newspapers, I meet a lot of people, I travel, and I had no clue. And I figured, well, if I have no clue, I'm sure I'm not the only one. And a lot of people probably don't have a clue either. And I think starting by talking more about who you are, and I'm not talking about advertising, I'm trying to, trying to get into broader discussions about climate change, about local energy projects, about planning, about funding. I think, you do, I'm sure you are involved in all these projects, but talking about the fact that you do it is probably what's lacking.
Awareness really is missing,
yeah.
isn't it? Benjamin, in our conversations prior to today, we touched on this subject quite a lot, that you go and visit cities other than Bordeaux. And you kind of have to begin the conversation from the start every time. What can we do to bring the level of awareness up so that you don't have to actually have a cold start every time? Where, is there a magic button?
The magic button, district heating.
Yeah. Of getting people to understand that putting these magic pieces together is where it's at.
I said, talking more about what we do, and maybe I suggest to operators not to wait after public sector, but it is the same thing for us, engineering company. We can start now to, for example, make the big plan that I talked about. That's what we do, and talk about it. I agree. Do the new parts of do what we need to do, as I said, and okay, talk about. And we will need help to do it. But when I talk about this industrializing process with all the colleagues here, we all agree to say, yes, we have to do it. So I don't think the button is difficult. We just have to start.
Just have to find it.
Yes.
Yeah. Finland, of course, is a special case. We all know this. Finland is the special country that just does everything well somehow. I don't know.
Very nice.
Why do they? It's like, they started in the sea. Well, they did. Jokes aside, one of the strength of kind of the Finnish success of the last few decades has been, of course, your approach to education. Are you seeing within the Finnish education system, are you seeing people actually talking openly and a lot and in detail about questions surrounding climate change and solutions for it? Or is it not a subject even in Finland just yet?
Of course, it's a subject, but I have to say that.
That is water.
Yeah, I have to say that. Of course, there's a lot of discussion that there should be more discussion. that can be seen in the newspapers, but we are discussing. But there's a lot of alternative views on what is the right way to tackle climate change. Also in Finland, I think that's now happening all around Europe. We have a little bit of dispute going on.
Perhaps one of the conversations that all of the people here might have is to figure out a way of putting together, I don't know, a few pages of basic information that can be distributed to others. And I don't know. I mean, this is an opportunity for a conversation, and conversation is the basis of civilization, right? But let's get into these engineering questions because they're actually quite cool. Let's talk numbers. Jukka, how many homes, how many apartments have you actually digitized? And how many are you going to digitize, and when?
Yeah, we currently have, I think it's 100,000 plus, and we are aiming to be at 1 million by the end of 2020. And we could do much more, but it's the psychology that's holding us back a little bit.
As always, it's never about the technology.
Yeah.
Can you talk maybe for a couple of minutes in detail about how this virtual heat plant works and how it helps lower energy consumption?
Like how much detail? 5 hours, 2 minutes. Yeah.
Oh God, I asked the wrong question.
Yeah, I showed that picture when I was the engineer picture. So, yeah, but I think it's quite simple that in the end, there's people, building owners, district heating utilities, and if you talk with them and you can show that you have something that provides a good payback time, then you have a business case. So basically, for example, virtual heat plant or cutting peak load, it's about using artificial intelligence to control the heat load so that we can avoid peaks in the system. So basically, for example, in the Finnish case, substations often have domestic hot water heating with instantaneous heat exchangers. And what the AI basically does, it learns the profile of domestic hot water heating, which goes up when people wake up and up when they come back from work. And we can use the AI to control the space heating circuit against that. A complex technical explanation, but in the end we get that 20% reduction of peak load, which is very valuable. And that's the reason why these virtual heat plants in general are taking off.
Have you seen, or have you heard or talked to people in your work in France? Have you seen examples of this kind of thinking of combining software, hardware solutions at that kind of level, or not quite yet?
No, we're quite advanced controlling systems, but not in that way exactly. We know how to prioritize the different use of heat in a building, but not in that way.
So
or I don't know, maybe it's the case, but I'm not...
Okay. One of the questions that we just received was how can engineers help each other take off those glasses which allow you to only look at the hard problems, and how can you help each other look at the important problems? What might be the triggers? Because I have an idea, but...
yeah, that's a super hard question. Yeah. I have to say that at least now I'm talking personally. I was first engineer, then an entrepreneur. So what teaches you is if you can ask money for somebody for your engineering. So, well, so paying customer is a very good person to teach you to keep your glasses and look at the right place.
It's not just the things that you can do, but also the things that you can get paid for doing.
Yeah, and
also the things that the world needs,
you're providing value. You're providing somebody value with your engineering.
So isn't that the answer? Where you can actually find the value and you can talk about the value and say, well, how do we get there?
Yeah.
How does the world of communication actually come into this?
The world of communication, as you said, is everywhere. There's no escaping it. And
How
I think,
can we help these people?
well, I think, we all have to realize that, as I said, we're all Peter. You're all Peter. All of us can make a difference. And if you work in an organization where you're in the top management, in which case it's easier to make the decision or trigger the decision, once the decision is made, once you're going down the path of improving things, what's important is that you need to get everybody on board. You absolutely need to communicate in-house to, no matter how big your organization, I'm thinking of Danfoss, which is a very big organization, and you have people at all levels, everybody must know that you have made the decision, you have started on that path, everybody's involved, everybody's part of it. Everybody in an organization, in a company, in an office, is your ambassador. And once that is established, and once people feel that, once people have a buy-in, have given their buy-in, it's so much easier. Because you don't need to convince anyone. Everybody will work at convincing the outside world.
If you're wondering how to approach this rather complex question, you might like to nab some of our Danfoss communications people who are here today, and they are among the best in the business. I'm not Danfoss, so I can say that. I'm impartial. So just nab them at the stand and have that conversation, because really talking about it is the path forward, isn't it? And just a beautifully highlighted message here from an engineer who really appreciates your message, Florence.
Thank you very much.
Now we've got all sorts of acronyms in here, which I have no idea what they mean, but I'm sure you do. This is a question that I actually can't understand. And this is so interesting that it's an Android tablet. Who'd use one of these? Come on. Wait a minute, let me just read this. Hold on. Okay, what could lead the standardization process for DHC system hardware software, and how to keep innovation options open? You guys.
Yeah, you go first.
Yes, during the days, 2 days and yesterday, we often talked about innovation, and we need it. We have to test new solutions. But if we think about the scale at which we have to work, we have to choose where to try innovation and where not to try it, and deploy district energy. We can combine the two approach, but it's not innovation or no innovation. We can do both.
Yeah, I have to say that, of course, hardware is more complex to find those standards, but in terms of software, we are in a situation where we would need to have that hardware place to be able to discuss about unifying standards on software. So the market of digitalizing buildings and district heating networks is still in the beginning, I would say. And when you're in such a beginning, it's hard to talk about standardization yet. So, but maybe on the hardware side.
I'm outside the industry, so I actually don't know the answer to this question. Because every good interviewer, of course, knows the answer to the question before they ask the question, so they can argue. I don't know the answer, and I'm really keen to find out. Yeah. Because, as you just said, the process is really just beginning. Yeah. Are there standards organizations? Are there people who meet twice a year and actually get the standards books written like they have for, I don't know, Bluetooth mesh or other complex network solutions? Is this happening in your business?
Not that I know of, at least.
Why not? No, seriously.
Maybe ask the audience.
I mean, you guys are the best in the business, right? Sit down and I mean, would it not be good to actually, in 10 years' time, read, now is the 10th anniversary of the standards organization having been created at Nantes in 2019? I don't know. Maybe we can finish up on that note.
Yeah.
Thank you.
Thank you.
Thank you.
Yupka, Benjamin France, much obliged. Thank you. This is the part I love the most when I get to say thanks to people, and there's always lots of thanks to be said. To begin with, of course, to our great speakers, thanks again. Thank you to Euroheat Power for the invitation. Big thanks to our wonderful production crew who've been with us since the very beginning. Magda and Patricia and Wojtek, and you guys are great. Without them, we'd be just tripping over our own feet. It would be a disaster. Thank you to the local production guys who've been most accommodating and very helpful. Thank you to you for taking the time to actually sit down and listen to this. Thank you to the people on the live stream. You've done well if you're still with us. Third cup of coffee down. The point of all this is to continue the conversations, not to just kind of leave here today and go, that was interesting, now back to my Excel spreadsheet. The point is to keep talking. So please do keep in touch with the people around the ET Talks project. The videos and the interviews from all the previous events, and also from this one, are all online. All you need to do is do a quick search for ET Talks and you'll find them immediately. And please keep in touch with us. You can tweet at me if you wish for some strange reason, at Ralph Talmont. You can tweet at anybody in the communications team at Danfoss. We're easy to find. And of course, the stand is there and our speakers are there. And one last thing, keep an eye out for the announcement about the next ET Talks project, which is coming up soon. Thank you, and have a good afternoon.